shapes. That's the second part of this unit. It's sort of its own standalone kind of idea. Surface area is the area on the outside of a shape. So sometimes we have a shape like a cube. I've got a cube here of my kids when they're really little, and it has 1, 2, 3, 4, 5, 6 squares that make up its surface area. So if I wanted to paint this cube, I'd have to paint 6 squares, and then I would, if I wanted to find out the surface area would be the area of 1 square times by 6. Now we're going to be doing surface areas of different shapes here. So we have prisms, we have cylinders, and we have triangular prisms. So the first topic, or the first definition we're looking at, is what is a prism? And basically what I would do to describe a prism is imagine cutting out a shape, like a circle. Take a piece of paper, cut out a circle. Then you decide you're going to take 500 pieces of paper and cut out that same size circle over and over and over and over again and stack them. Does it make sense that if you stack them, you would eventually get this shape? Just like a stack of paper makes a rectangular prism. So anytime you have the same shape stacked over and over and over again, you make a prism. And what's really cool about prisms is, what's this called when I stack everything together and say this is the whole thing that it's taking space of? There's a word for that. It's hard to describe it without saying the word. What's the word we call for an object's space that it takes up? Whew. Area is the top, bottom, and sides, right? That's surface area. And area, if I want to find the area of a paper, that's just 2-dimensional. But if I go to 3 dimensions, I call that volume. And what's really cool about the formula for the volume of any prism, the volume of any prism is going to be the area of the base times the height. Because you take one circle, that has an area. You keep adding circles to it until you get to a certain height, and that fills up that whole shape. That's the volume, which is a really powerful formula. So if I wanted to find the formula of the triangular prism, I would find the area of the triangle and multiply by the height of that prism. In fact, I would probably redraw the triangular prism like this, so that you can imagine it sitting, and this would be its height, right? But if it was labeled like this, you'd have to go, oh, now my height is this part, because it's not laying with the base on the bottom. Okay, next definition. A pyramid. And pyramids are shapes that start with some shape at the bottom and then go to a point at the top. It has one base and a point at the top. There's a special name for a pyramid that has a circle at the bottom. What do you call that? Yes, cone. Brings back good memories of ice cream. Yeah, just here. Put part 1 down there and grab part 2. So I have these blocks here, and they kind of click together. And one of the things that we're going to be doing is talking about surface areas of shapes that are put together. And we're going to start off with surface area of shapes that are put together with cubes. So if you want, you can come up and grab some cubes. Sometimes it's easier if you can visualize it yourself in front of you. So what you want to see if you can do, Jackson, see if you can build that. Okay? But sometimes one of the skills that we're also trying to do in this class is see if we can visualize things without having to build a model. That's sort of the next level. So you're always allowed to build a model to start with if you want. So here I've got 3 in the back, then 2 in the front, then 2 on top. I'm feeling pink today. Some of these don't click together as nice as others. Some of them don't click together as nice as others. There we go. Did I make it right? Does it look like the right shape? Some of them click nicely, some of them don't, eh? So we have the shape. Now, if we want to find the surface area of this whole thing, does it make sense that the surface area is a whole bunch of squares added up? And what we need to figure out is how many squares do we have in total? So for example, if I measured this with a ruler, and I've got a ruler here, real life cubes are not necessarily the nicest. It is 1.5 centimeters by 1.5 centimeters. So the area of one of these sides, we'd have to take out our calculator, 1.5 times 1.5. 2.25. All right. That was a little harder mental math than we should have. Real life examples often don't have nice numbers, right? 1.5 centimeters, we're like, oh, I wish it was 1 centimeter. Because if it was 1 by 1, you'd be able to say the area no problem. 1 times 1? 1. But 1.5 times, yeah. I did 1.5 times 1.5, 2.25, and you were like, no comment. I do 1 times 1, and you're in amazement? So once you find the area of one of these sides, so one of these sides is 2.25 centimeters squared, you would have to figure out for the surface area how many squares are showing. And so if I'm holding it, I could start counting. Like on this side, I have 1, 2, 3, 4, 5, 6. And then I have 7, 8, 9, 10. And it falls apart. But it can get a little frustrating if you turn it around, you forget which sides you've counted, which ones you haven't. And so one of the things that we're going to do for each of these is to draw the 6 views. Every time you have a shape, you can see it from the front and from the back, the top and the bottom, the left side and the right side. Then you can count the squares in each of the views and add, well, then you would have the total area. So here is that first shape. Okay? Can you see from the top, this matches up? Here's the shape to begin with. You have to imagine looking from the top, which if you have the shape built, sometimes that's a little bit easier. That's the top. The bottom is exactly the same. Although when I actually turn it, I actually like, you don't have to change this, but this is my own. When I turn it and look at it at the bottom, I see that. I see the L like this. From the top, I see it like that. The bottom, I see it like that. Wouldn't make a difference on how many squares that I see. Okay? From the front, can you see that this is the shape from the front? I can't believe how perfectly this matches up with the smartboard. I'm so, like, it's like, ooh, bing, perfect. Then flipping it around from the back, I see the same ones. From the right-hand side, so here's my original shape. I turn and look at it from the right, and even though it comes out, as far as what I see is an L shape. And from the left, it makes an L. So exciting. Wait, you just realized that that was the letter L? Oh, okay. I was like, whew. So in this one, we ended up with 5, 10, 20, 30 squares. Often these questions have things in place where they say each square is a perfect 1 unit by 1 unit, then the surface area is going to be 30 times the area of 1 square. So if we actually did these pink cubes that I had, I'd have to take 30 times 2.25. Okay? If we were using a question like this one, I believe this question, if I have the notes here, they didn't specify, or did they, how big 1 square was? No, they didn't specify how big they were. So let's do it. We found out that 1 square, let's draw the 1 square, it was 1.5 centimeters by 1.5 centimeters. So the area of this one was 2.25 centimeters squared. The total surface area then is 30 times 2.25. And 30 times 2.25 is 67.5 centimeters squared. Okay? For the next example, I stole it from a French immersion website. So this word out in front, you can put a line through it and you can write front there. You want to see if you can build that one? Yeah, some of them are terrible, aren't they? All right. I'm hiding them. I want you to draw the front one. I will put up the answer in a bit. I paused the video so that it wouldn't be boring, and then I didn't unpause it. So here are the front, the top, the bottom, the right, the left of the last ones. And we figured out the surface area was 184. units squared. So I'd like you to try the next one to draw the shapes. And I'm going to come here, grab some of these. Okay, I've got to hand some out. Do you want squares to make it first to draw it? You're good? Do you want to try? You want the squares to make it? There's a big chunk already. Find the gray ones seem to be better. There's a bunch of blocks. Do you want blocks to try to build it? You want blocks to try to build it? Okay. Kale, do you want blocks to try to build it? Decision making. Yes? No? You're okay? Do you want blocks to try to build it? You're all good? Cass, you want blocks? Nora? You want blocks to try to build it first? Yes. Did you hand out some extra notes? Just today. I'm just trying to. I've got. Okay. Here we go. I'll bring them back. Don't worry. There you go. Anybody want blocks here? You good? Oh yeah. You're welcome. So in a question like this, if you do have the blocks, first I would count out 14 blocks. Try to build it with those 14 blocks based on what you can see. And then, again, I stole this picture from a French resource. This is front. Here are the answers. How did you do? Okay. And if we 7, 7, 9, 9, 7, and 9, if we add up all of our squares, we have 48 squares. Each one has an area of 9. Here's the left side. 2 with 1 out front. This is the front now. You still had the front the other way. And that, as long as you're labeling things, but this one, the front was labeled as a bit of a turn. So your shapes might be switched based on if you thought the front was a different spot. Again, this is the skill that's being taught in this unit. Can you take things in your head and visualize them how they're going to be?
But we should have 4 sevens, right?
Oh yeah, 4, 7. Yes, this is a 7. Thank you. And that will cut this down to 46. 28 plus 18, 46. 46 times 9, 360 and 54. 414. There we go. Yeah. Our next questions deal with formulas. I am going to give you your grade 9 formula sheet. Okay. They're come in different colors, so if you don't like the color you get, so I'm going to get you to add the 2 centimeters because the bottom of this is a square. So this is called a rectangular prism. Now on your formula sheet, you have the following formula. The surface area is 2LW plus 2LH plus 2HW. So when you're looking at your shape, depending on how you look at it, you could have different values for what's your width, what's your length, what's your height. Okay? If you look at this, maybe you decide I'm going to make my length 8 centimeters, my width 2 centimeters, and my height 2 centimeters. So one way that you can calculate the surface area of a prism is to use the formula, write out the things that you have, and then it's just a matter of substituting in. So the surface area will be 2. Put brackets. What are we going to replace the L with? The L is 8. The width is 2. Plus 2, the length is 8. The height is 2. Plus 2, the height is 2. The width is 2. So method 1 is that we can figure this out, given the formula that we have and writing things in. Then it's just a matter of multiplying. 2 times 8 times 2, that's 32. 2 times 8 times 2, that's 32. And 2 times 2 times 2, that's 8. We get our surface area, 72. We have to look, was there units? Yes. Area is always something squared, so we have our surface area equals 72 centimeters squared. That's method 1, using the formula. The problem with formulas is sometimes you don't have them with you. Sometimes you're trying to figure out a question and you don't have a formula with you, so I want to make sure that you guys understand, what does surface area mean? It's adding up all the areas of all the sides. Can you see that if you did your left and right, you would have 2 squares that are 2 by 2, this side and this side. And then around, you would have 4 rectangles that are all 2 by 8. If you think about the shape, you can open it up. And if you open it up, you could figure out the area of each. 2 times 2, this will be 16, 16, 16, 16. If you add up all of those areas, you also get 72 centimeters squared. And we don't need to use a formula. Formulas are nice because we can plug things in. But sometimes it's nice to be able to understand what's happening as well.
Comes into play on the next one, that style. Because that almost prefers that second style.
Yeah, if we look here, we do have this shape on our thing, but look at the formula on our formula sheet. It just says calculate the area of all the sides. So we do have to use so break up all your sides. Can you see that you have 2 triangles? And can you see that this is made up of 3 rectangles? Are you okay if I color code things? I just did my 2 triangles in blue, but I'm going to show you, I'm going to do this rectangle in green. On that rectangle in green, one side is 10, one side is 12.
10 is for the height going this way.
Nope. The 10 is in the right spot. This is on my triangles, this is 8. The hypotenuse is 10. Make you work. This rectangle, my purple rectangle, can you see that it's 8 by 12? And then I have an orange rectangle. The orange rectangle, the only thing I know on the orange rectangle is the 10. We have a problem. We're missing a side. So we have to figure out the missing side. Any ideas? Some people wanted to just make it 8 because there was already another 8, so let's just make it 8 again. Unfortunately, that is not allowed. That's not how it works. So you have to find something. There's something given here that is a hint that we can find the last side. Would it be what? It's not 12. The hint is in the triangles. What do you know about triangles that are right-angled triangle? A squared plus b squared equals c squared. C squared is always the hypotenuse. So you know the hypotenuse is the 10. You know that the one side is 8. You need to still find a squared. You would get a squared plus 64 equals 100. A squared equals 36. Square root both sides, which is normally plus or minus 6, but since it's a length, we know that a has to be 6. So now I can add that 6 onto my diagram. Now, surface area. How do you find the area of a triangle? Is it on your formula sheet? It is. It's 1/2 base times height. So the area of this triangle, ooh, I wanted to use blue. Oh, maybe I'll do all the areas in their own color. I'll go black. The area of this one, 24. Base times height divided by 2. 6 times 8 is 48, divided by 2, 24. This one, same triangle, also 24. Area of that rectangle, 6 times 10, 60. Area of this rectangle, 120. And area of this rectangle, 96.
Sorry, where did you get the 6 by 10?
That would be this orange one on here, and that's why I color-coded it.
Wouldn't it be 6 by 12?
Oh, thank you. Yes, because I saw the 10 here when I drew it. You're right. Appreciate that. We got it. It is 6 by 12, which makes it 72. Then we need to add everything up.
Are those 29, 48, the triangles?
They're 24 and 24. 48. Did anybody add this up? Did you get 336? And it's centimeters. So our surface area is 336 centimeters squared. The next formula is one of my favorite formulas for surface area. You ready for it? We have a cylinder. So you look at your formula sheet, and your formula sheet says the surface area of a cylinder is, and I'm going to color code some stuff here, 2 pi r squared. Oops. Which happen to be 2 circles. Can you see that there's a circle on the top and the circle on the bottom of a cylinder? I even want to color the top. There we go. Color the top in with my wonderful crayon. Okay. And then you have plus, what color should I use for this? Check out my crayons. I've got purple. I'm going to go purple. The coolest thing about the purple part is if you take a cylinder, and this is pretty close to a cylinder, it's just a little bit funny shaped at the top if I take this thermos, And if I want to find the purple part, which is around here, okay, the best way to visualize this is when you go home today, go into your cupboard, and if your parents have a can of soup or a can of tomato sauce, rip off the label. Have you ever taken the label off of a can of something? What does it make? What shape does it make when you take off the label? Doesn't make a sphere. If you take the label, here's a label, look at how this fits perfectly. You pop it off, it makes a perfect rectangle. Okay? That rectangle, so we can draw over here 2 circles and 1 purple rectangle. This is the formula for a surface area of a sphere. Again, I'm having way too much fun coloring today. There's the purple part. And 2 circles on the top and the bottom. Okay? You know what's super cool about the purple part? The purple part has the height here of your cylinder, which happens to be 12 centimeters, but this length from here to here, what is that called? That would be like from there all the way around to there. Yes, that's the circumference of your circle. And the circumference of your circle, the formula is 2 pi r. Notice this formula is just circumference times height. That's why I like this formula so much. It has so many cool things built into it. So, what could we do? This is the visual. If we wanted to find out the actual surface area, we already know that your height is 12 centimeters. Do we know the r? Does the question tell us the radius? Sort of. What does it tell us? The diameter. How can we find the radius if we know the diameter? Cut in half. Perfect. And so now we can figure out the surface area. For the green parts, you have 2 pi, and you know your radius is 5, and it needs to get squared, plus the purple part, 2 pi. We know the radius is 5, and we know the height is 12. You should be able to, on your calculator, type this whole line all at once. So I can figure out my total surface area is going to be, and I go to my calculator. Try this right now. See if you can type 2 times pi times 5 squared plus 2, and you can put brackets if you want, times pi times 5 times 12. Please take out your calculator and show me that you were able to get this number. And it's area, so we need to have centimeters squared. So I'm going to walk around, check your calculators.